Hi, in this video we're going to talk through some revision notes on electrolysis. So you can see here, electrolysis is when an electric current is passed through an electrolyte and the compound decomposes, so it breaks up. Now ionic compounds don't conduct electricity when they're solids because their ions are all in a fixed position in the lattice. However, if you melt them or dissolve them in water, the ions are then free to move and carry the charge. So I'm going to start with an example here. So we're going to start with molten compounds. It's easier when it's just a melted compound. So we've got here lead bromide, so PbBr2. It's called lead 2 bromide. That tells us that the charge on the Pb is a 2+. And you can see the ions we've got present here are our lead plus and our bromide, which is a minus ion. Now I've drawn a little diagram, or attempted to draw a little diagram. So you can see we've got the anode, the positive electrode, the cathode, which is the negative electrode, and then our electrolyte here. So this will be our molten lead bromide. Now, what you'll be asked to do is predict the products that are formed at the anode and at the cathode. So the anode is positive, and that means that the negative ions will be attracted there. So in this case, that's the bromide, okay, because the bromide is negative. Now, when they are attracted to there, they turn back into what they would normally be. So in the case of bromide, it would normally be bromine. So we're going to have here our Br minus. Now because it's a negative, it's got to lose electrons to get back to being neutral. Okay, so it's going to form a Br2 because we know that bromine goes around in pairs. It's a halogen. Each bromine had this extra electron to make it a bromide ion, so it's going to have to lose an electron, and when we lose electrons we pop them on the right hand side. Now you'll hopefully notice this is not balanced, so I've got 2 bromines here and only 1 here, so I want to pop a big 2 in front of there, and because each one has lost an electron, I'm going to have 2 electrons there. Now because that's loss of electrons, that is oxidation, because oil rig, oxidation is loss of electrons, reduction is gain. At the cathode, that's the negative electrode, that's where our positive ions will be attracted to, so that's the Pb2+. Now it wants to get back to just being normal Pb, so it's going to have to gain 2 electrons because it's got a 2+ charge, and then it will just form normal Pb. Okay, normal lead. Now that's reduction because it's gained an electron, and oxidation is loss, reduction is gain. And you can see that overall we started with PbBr2, and what we've actually formed is this Pb here at the cathode, and at the anode we've formed the Br2. So that would be your overall equation for what's happening there in that electrolysis reaction. When we look at solutions, it's a bit different. Okay, and there are 2 rules that we need to learn. So because our solution includes water, we've also got these hydrogen ions and these hydroxide ions. They're present, they come from the water. Okay, because water, you can see at the top here, water is actually made up of hydrogen ions and hydroxide ions. So there are 2 rules to learn, and we apply them every time we do electrolysis of solutions. So the rule number 1, if the metal present is more reactive than hydrogen, then we don't make the metal, we make hydrogen instead. Okay, and the half equation for that will be 2H plus 2 electrons gives you H2, because hydrogen goes around in pairs, it's diatomic. The second rule is about negative ions. If there is a halide ion present, so that's something from group 7 like chloride or bromide, then the halogen will form chlorine or bromine, etc. If there is not a halide present, then you will form oxygen, and the half equation will always be this: 4OH minus gives you oxygen plus 2 waters plus 4 electrons. So that's coming from the hydroxide ions that we have there from the water. Now, we're going to do a couple of examples with aqueous solutions. With molten compounds, and then we'll look at aqueous solutions. So we're going to start with molten calcium chloride, so CaCl2. So the ions that we've got present are going to be Ca2+ and Cl-. Now if you're not sure how I got that, you need to look at your periodic table. So calcium's in group 2, so it always forms 2+ ions. Chlorine's in group 7, so it forms 1- ions. So they're the only ions I've got present. So at the anode, that's positive. This negative ion will be attracted there. Now we know it wants to get back to being how it would normally be, which in the case of chlorine would be a Cl2, okay, because it's one of those ones that goes around in pairs. So it had an extra electron, which it now needs to lose. That will appear there. And we need to make sure it's balanced. So I've got 2 chlorines here, but only 1 there. So let's pop a big 2 in front. each one of them's lost an electron, so I need a big 2 there as well. At the cathodes, that's my negative electrode, that's where my positive ions will be attracted, so my Ca2+. Now that's going to have to gain 2 electrons to get back to being just normal calcium, because it had a 2+ charge. Okay, and again we can write an overall equation for this. So we started with CaCl2 and we've ended up with Ca and Cl2. Okay, if we look at aluminium oxide, we've got aluminium ions present, that's Al3+, and oxide ions present, that's O2-. Now because it's molten, that's the only thing we've got. Okay, at the anode, that's positive, that's where our negative ions are going to be attracted, that's going to be my O2-, and it wants to get back to being normal oxygen. Now oxygen goes around in pairs as well, okay, so it's going to have to form an O2. Now to do that, it needs to lose 2 electrons each. Okay, but I'm just going to put electron for now and I'll add my number in a minute, because this isn't balanced either, so I've got 2 oxygens here and just 1 here. So I want to pop a big 2 there to make my oxygens balance. Each oxygen had 2 electrons to lose because it had this 2- charge. 2 times 2 is 4. So I'm going to have 4 electrons here on the right. At the cathodes, that's my negative electrode. That's where my aluminium will be attracted. So my Al3+. To get back to being normal aluminium, it's going to need to gain 3 electrons because it's got a 3+ charge. And we can again write an overall equation here. So we started with Al2O3. We've ended up with aluminium and oxygen, and then we need to make sure that that equation is balanced. Okay, so I've got 2 aluminiums here on the left but only 1 here, so I'm going to pop a 2. I've got 3 oxygens here and 2 oxygens here. Now we don't like odd numbers, so I'm going to double this end, and that gives me 2 times 3, which is 6 oxygens, so I'll pop a 3 here in front of my oxygen. You'll notice I've unbalanced my aluminiums. 2 times 2 is 4, so I'm going to change that to a 4. Now we're going to have a look at some examples now of the solutions. So this is where it gets a little bit more tricky. Okay, so we're going to start with copper 2 sulfate solution, which is CuSO4. I think you guys can see that. So the ions that we've got present, we've got the copper ions and the sulfate ions. That's what we would expect. Because it's in solution, that means there's water present. So we've also got the H+ and the OH-. Okay, so we've got 4 ions to choose from here. And this is where those rules come into play. So at the anode, that's the positive electrode, we're either going to have oxygen or, hydrogen or copper. And we need to look at the reactivity. Okay, the rule was if that metal is more reactive than hydrogen, then we don't form the metal, we form hydrogen instead. But actually copper is not very reactive. Also, I've done this around the wrong way. Copper is not very reactive. I'll start with the cathode. Copper is not very reactive, so we're going to form that one. Okay, so it's going to have to gain 2 electrons to get back to being normal copper. Sorry guys, done that the wrong way around. Then if we go up to the anode this time, we've got 2 negatives. We've got this sulfate ion and this hydroxide ion. And the rule was, if there is a halide present, then we form the halogen. If not, we make oxygen. Now there's no halide present here. None of these are in group 7. So we're going to make oxygen, and that comes from the hydroxide ions. So the equation's always the same, you just need to learn it, I'm afraid. So 4 hydroxide ions gives you oxygen plus 2 waters plus 4 electrons. Okay, we'll do one more solution example. Just sort my paper out, it's a bit windy. Right, so sodium bromide solution, NaBr. Again, we want to look at the ions we've got present. We've got sodium ions and we've got bromide ions. And then because it's in solution, it's in water, we've also got hydrogen ions and hydroxide ions. Okay, so we'll start at the anode. We need to look at what we're going to have attracted here. So it's either going to be this bromide or this hydroxide. And we need to think about the rule. The rule says if we have a halide, we make the halogen. Otherwise, we make oxygen. Now, bromide is a halide. It's in group 7. So we're going to make bromine. So we're going to have our bromide, it's going to be coming back to bromine. Now each one of these bromide ions has got an extra electron, so it needs to lose that electron to get back to being neutral, and then we need to check that it's balanced. So we've got 2 bromines here, so I want to pop a big 2 in front here. Each one of them's lost 1 electron, so then we need a 2 there as well. If we look at the cathode, that is where the positive ions are coming, so either sodium or hydrogen. And the rule was, if the metal is more reactive than hydrogen, then we form hydrogen instead of the metal. Sodium is very reactive. Okay, so we're not going to form sodium, we are going to form hydrogen. Hydrogen will need to gain an electron to get back to being neutral. Hydrogen goes around in pairs, it's H2, so we want to make sure we've balanced this out. So we've got 2 hydrogens here on the right, so we want to pop a big 2 in front on the left, and each one of them needs to gain 1 electron. So that's going to be a big 2 there as well. And I've popped an extra question at the bottom here, which is there another product? So have a look. We have used up, you guys see that? Yeah. We've used up the hydrogen ions and we've used up the bromide ions. So what's actually left over is a sodium ions and hydroxide ions. Okay, so our extra product will be sodium hydroxide solution. So that will be left. It won't be forming at either of the electrodes, it will be left in the beak or whatever you were using. Okay, so we will have sodium hydroxide solution left, which is NaOH.